So now we're going to look at motion, more general, but still simple, moving in a straight line, but either starting from scratch, from standing still and starting to move, or it's moving and speeding up, or moving and slowing down and stopping. Okay, those kinds of motion. Now, our hypothesis is that if something will be exhibiting that kind of motion, there must be something pushing on it. And we'll just use a term, we'll call it a force. Okay, it's nothing more than, it's not, now we know what it is because we gave it a name. We're just giving a name to that phenomenon. Something is causing it to stop, to slow down, to speed up. If you exert a force on something, what will happen to it? Okay, the two cases we have are something standing still and something just moving like that, that boring object just moving like that, right? Neither of them have any forces acting on it. If they did, what would happen? If this had a force acting on it, what would happen? It wouldn't be just standing still. Of course, it could have two forces acting on it, one pushing this, one pushing it, it won't move, but, right? If it has an unbalanced force acting on it. Does this one have a force acting on it?
No.
Okay, we got a yes and a no.
If there was a force, it would stop, right?
Okay. So let's take a pose. Okay? This is moving like this, in outer space, at a constant speed, in the same direction. Okay, is there or is there not a force acting on it?
No force.
Then why is it moving?
That's the emission.
Pardon?
It's just a temporary thing. It's just, whatever pushed it is no longer pushing it.
Okay, if what was pushing, what initially pushed it was still pushing it, what would you expect to see? It would change the motion. Okay, if something is not changing its motion, right? It's not changing its motion, either standing still or moving like this, or however fast it is, right? Just moving straight. It means there's no forces on it. In order to start moving or stop moving, it has to have a force pushed on it. But the fact that it's moving is not because there's a force acting on it now. The fact that it's moving now is because it was moving. And if it was moving, it'll continue to move forever. Okay? Once it's moving, again in outer space, there's no gravity pulling on it, there's no friction, there's no air resistance, nothing. There's no reason for it to stop. In order to move, it doesn't have to have any forces acting on it. So if we see something moving in a straight line with a constant speed, no forces are acting on it. Or there might be two forces equal and opposite pushing against it like this, one like this. It doesn't do anything. Just like if it was standing still, they wouldn't do anything. If it was moving, it won't move. So there's no net force acting on this. Not in this direction, that direction, any direction. There's no net force. There may be many forces, but they cancel each other out. It'll just continue moving like that. Again, to move, something has to start it moving. But to stop it, something has to stop it. It won't just stop by itself. So it's very, very important to remember. Inertia, if something is standing still, it'll stay still. If it's at rest, it'll stay at rest. There are no forces acting on it, or the sum of the forces are zero. There's no net forces. Okay? If there is a force acting on it at some point, what will happen? It'll slow down, it'll change directions, right? Something will happen. The motion will change. Okay. If it's moving at a constant speed in the same direction, it'll continue moving forever. Now, does that make sense? That something is just moving along forever without any force acting on it? Well, this is what came up partly from our intuition, partly from our experiments, partly from our extrapolation. Saying, okay. And this is the way it seems that nature works. So forces cause changes in the state of motion. Not motion itself. What it does is it changes the state of motion from, let's say, rest to moving, or moving to speeding up in a different way.